Understanding memory is a very important aspect of understanding your computer and system hardware. Complaints that are common regarding your system memory if your computer is frequently frozen or whatnot, and that is a normal phenomenon. This is because the memory is about what you can run on your system and all sorts of features. And that's why there are system memory requirements, just like there are storage requirements, processor requirements, even graphics requirements for most applications. So, very important terms when understanding memory are parity checking, which I believe is commonplace nowadays, error correction code ECC, not a typical feature on the desktop, but it is typical on workstation and server devices, single and double sided memory, and also single, dual, triple, and quad channel memory. Parity checking is a rudimentary error checking scheme that offers no error correction. It works most often on a byte or 8 bits of data. A ninth bit is added at the transmitting end and removed at the receiving end, so it does not affect the actual data transmission. If the receiving end does not agree with the parity that is set in a particular byte, a parity error results. The four most common parity schemes affecting this extra bit are known as even, odd, mark, and space. Even and odd are used in systems that actually compute parity. Mark is a term for a digital pulse or bit, and space is a term for a lack of a pulse or a zero, so mark is a 1 bit, and space is a 0. These are used in systems that do not compute parity, but expect to see a fixed bit value stored in the parity location rather. Systems that do not support or reserve the location required for the parity bit are said to implement non-parity memory. The most basic model uses 8 memory chips to form a set. Each memory chip typically holds millions or billions of bits of information, each in its own cell. It depends on the memory size and whatnot, and then you might have, for instance, one 32-bit 72-pin SIM satisfies a bank for an old 32-bit CPU such as an i386 or i486. Two such modules are required to satisfy a bank for a 64-bit processor, like a more modern Pentium. Not the early Pentiums because they're 32-bit, but only a single 64-bit 168-pin DIMM is required to satisfy the same Pentium processor. For those modules that have fewer than 8 or 9 chips mounted on them, more than 1 bit for every byte is being handled by some of the chips. For example, if you see 3 chips mounted, the 2 larger chips customarily handle 4 bits. A nibble from each byte stored in a third handles a single parity bit for each byte. Error checking and correction is ECC. Single and double-sided memory, these are how much some memory modules have chips on one side and others have it on both sides. And the channel is based on the number of slots and sockets available and